Hello and welcome to another video. I know that the uploads have been rather inconsistent these past few weeks, but a lot of them were unplanned. However, I decided to delay some videos so that I can stay focused. So I have the ESP32 Pico PCB video series in the works, but that will be delayed until this series is done. So this will be part 1 where I test phase 2 of my Pico W controller PCB. I added the paid promotion tag as PCBWay reached out to me and asked me to collaborate with them again. Once again, thanks to PCBWay for the opportunity, and I will link their website in the description if you wish to use their services. In this video, I will cover the mistakes of phase 1, the lessons learned, the new design, run basic tests, and then draw some conclusions at the end. Let's get started. Before we begin, I will link the GitHub repo of this PCB in the description, which contains the Gerber files and the Fritzing files, which you can modify as you wish. I will also post a playlist of the phase 1 tests in the description below if you'd like more context. And as you can see, here were the mistakes. First, I double grounded the forward button. You can see this is ground when in fact I should have used this pin under here. The ground and GPIO pin share the same area of the button when they should be separate. And this is not related to the design, but there were solder balls on the potentiometer that prevented it from working properly. I will link the video up in the card above so you get more context as to what happened. I will also link the Medium article related to this video in the description if you'd like to dive deeper. So now let's get to phase 2. Alright, here is the new design of the PCB, and as you can see, I fixed all of the original design issues of the original design and added an LED and resistor. So one thing I did was, of course, use the correct GPIO pin for forward, so no longer it's double grounded. I fixed the ground issue, so now they're in different places. And on the LED and resistor, you can see that one leg is for the positive, which is the anode, and the cathode is for negative, which connects to the resistor, and the other side of the resistor connects to ground. And yes, I triple checked to make sure all of the GPIO pins were correct. And yes, I used copper fill like always. The potentiometer is still in the same area because the pins were correct. So when I received the boards, I made sure to use the correct amount of solder, and after running the basic test, everything ran smoothly. So yes, there were no more solder balls here, and I get all the buttons registered. So now let's run some basic tests. Alright guys, let's start with this demo here. This is the test PCB.py code. It's very simple. We import our libraries here. We define our buttons here. And in this loop, we will print statements based on which button is pressed. And if no button is pressed, it'll simply say not pressed. And we have our sleep here, which is 0.1. So it's a very tiny delay. Alright, so let's get started. So we're going to press run. As you can see, the buttons are working as expected. I would have been disappointed if none of the buttons pressed. Alright, so let's stop here and let's move on to the next demo. Alright folks, so let's work on this one. It's another simple code. This time it prints the values of the potentiometer, and then we have a small delay. So let's just run it. And as you can see, it's at 0. So you can see it's actually working a lot better. And you can see it's running just fine. And there you go, it's at 1 now. Now let's take it back. And you can see it's actually working very well this time, which means there's so many possibilities for this. But this is working a lot better than the last phase, so we'll send it back to 0. And we'll stop. Alright, so we have a successful potentiometer test. So now let's move on to the other tests. Alright folks, so here is the code. It's very simple 3-line code. This blinks the LED twice. So I'm going to run it down. So here it is. And there you go. The LED is blinking, and yes, I am using my Pi camera to record this footage. So that's it for this demo. Alright folks, so let's move on to the next demos. So we're going to first start with blinking the LED with the button. So here's a very simple code. So we have the button at pin 0, pin 3 is the LED. So we print on, or we have LED on when the button is pressed, and off when it's not. So we also added another small delay. So let me show you. I'm going to press the button. So I'm going to start the code. Making sure it's started. There you go. So, and you can see it's working properly. Alright, so let's end that one. Now, so you can see it's done. So now let's move on to the next one. This is very simple. It basically converts the values of the potentiometer to brightness values for the LED. So I'm going to do that now. So you can see, going to turn it up, you can see the LED get brighter and brighter and brighter. I'm doing it very slowly. Now I'm going to reduce the brightness. And there we go. So let me stop the code now. And, well, that's it for our demos. So that's it for this video. You have now seen the Phase 2 PCB working compared to the original. In the next part of the series, we will run the updated potentiometer BLE tests. After that, we will run the updated button BLE tests. And finally, I will show you the controller running a Raspberry Pi robot. So stay tuned and see you next time. Also, I want to be clear that when I did record the Raspberry Pi camera footage, it looked a bit slanted, but don't worry, it was the mounting bracket that was the issue. But it should still work just fine. So, see you next time.